All right, everyone. We had a few more people join in, so we're going to get started here. My name is Vincent Tui. I am the Sales and Application Engineer at High Tech Automation, and I am a Siemens specialist. So today we're going to be talking about the ET200SP2, the Open Controller. This is a pretty unique controller. They call it the Swiss Army knife of the PLCs. There's a lot of new features as we're going to see. Starting off, before we jump into the Siemens hardware, just give you a brief introduction to high tech. High tech automation, we're a distributor. Siemens is one of our main lines. We have many other. And we exist to help you along your automation journey in any way possible. So if it's a napkin sketch of a system that you want to build, or if it's a complete design, or if it's supporting your system and needing to do maintenance or obsolescence issues, handling those, we can help you with that as well. We are located in 4 different states. So we have Phoenix, Arizona, Utah, Colorado, and New Mexico. We have a number of Siemens certified specialists on board. And me and my team are very capable at helping with any issue that you may have with Siemens. High-Tech also has a online store, an e-commerce store. Here you can find list price, inventory, track your orders, and actually submit orders as well. It's real easy to get started. Just go to store.hightech.com. You can create an account right away, and that'll get you going on using the store. And real quick, our line card. So we're going to be talking about Siemens and the PLC today, but there's a lot more that we do. We do drives and pneumatics, HMIs, IO, robotics. We do conveyors. Some of our other lines that are pretty large are like Vesto, 8020. We do a lot of mechanical assembly, cutting in the shop, as we'll see on the next slide here. We can cut 8020. We can do Highland rails. So if you have a custom design or something like that, we can cut it, we can build it, and we can put a unique part number on it as well. So getting into the Open Controller. So here you can see in the picture on the left side is the Open Controller. It has a giant heat sink in the middle of it, and then a number of ports on the left side. And we'll get into details about those overall. But the reason why this is called the Swiss Army knife for Siemens PLCs is it has a operating system alongside with the PLC operating system. So you can get a Windows 10 operating system or a Linux running alongside your PLC. And so maybe asking, why do I need a PC-based controller? We have other PLCs. Why use PC-based? Well, we have 3 questions here, and if any of those are yes, then that's where the Open Controller starts to make sense. And what I've seen in the field, a lot of times, you have a custom application, Windows or Linux, and that will, you need to run that side by side with the PLC. You need the PLC to have access to it to execute a function within that application. Or you have your own C, C++, or Visual Basic script or program written, and you want to be able to use that along with your PLC code. Another question is, do you need all the functionality of the 1500 with the PC-based controller? So, all the functions you may be used to, function blocks, security, the diagnostics, traces, all that goes into the 1500, plus the advantage of having the PC side by side. And then, if you are currently using a PC-based system, you need it to be independent of Windows. Everyone's aware Windows can have a blue screen of death, it can crash, it can stop running, and for an automation system, that's not good for us, right? We need minimal downtime. We need to be sure that our controller is going to be running 24/7, for years, 5, 10 years at a time. So going down is not an option. And so something that's unique about the Open Controller is that the operating system and the PLC are completely independent at the kernel level. So it's not like we're running an application on top of the operating system. We're actually running the Step 7 operating system side by side with the Windows operating system. So Siemens took this criteria and said, okay, well, how do we make the best open controller, the best PC-based controller in the market? Then they took some of these ideas. So avoiding downtime, right? So we said has to have high availability. So the PC side boots up immediately. You don't have a long load cycle for an operating system like you would with a standard PC or laptop. Scalability. So you want to be able to hang some I/O on it pretty easily. I've seen a number of PC-based controllers out there, and you have to have all the special wiring and hardware to hook up to industrial automation hardware. So Siemens wanted to find a way to quickly attach I/O and other communication cards or modules to a controller. Standardization, reuse of programming code. So Siemens already has the 1,200 controllers, the 1,500 controllers, and they want to be able to use the same program and code, you would in one of those controllers in the Open Controller. And then as well as having some function blocks to access those other outside third-party applications that might be in C or C++. And then, security is the last one I'll touch on here. And so protection of intellectual property and authorized access. How do you keep people out of your PC? So these are just some of the criteria that Siemens put in mind first and foremost when they designed the Open Controller. And as I showed in the imagery before, this is what they came up with. So we're going to go through, some of the hardware. We'll go through the hardware and software throughout this presentation, but right now I'm just focusing on, what do we see up front? Important point to be aware of is the fanless design. So there's no moving parts within this controller. That helps us with our temperature range. We're able to operate up in 60 degrees C with that large heat sink. We have 8 gigs of RAM that is dedicated to both the PLC operating system and the Windows operating system. And those are going to be completely separated, though they're not shared together. So you're going to have allocated RAM. And then as far as PC interfaces, we have a display port, we have USB 3.0, and we have a gigabit Ethernet port right there. We also have the bus adapters, which is a little bit hard to see in this picture. The next slide over here, there's a vertical column here. I believe I can get a laser pen right here. This guy right here is a bus adapter. So that will actually give us 2 ports, RJ45 ports or fiber optic ports, to connect with our devices and to our automation networks. You still get, like you would with any other 1500 controller, you get some status LEDs to see if it's running, if it's faulted, if there's a warning. Obviously power LED, a switch for run mode, stop mode, or memory reset, and a slot for the MMC card. And then over on the right here, we're showing some I/O cards. So basically, how this works is it actually plugs right in to the controller. So in the center here is a CPU, and on the right side here are different card types. So you can have communication cards, I/O cards. The yellow cards are fail-safe cards. And on the left, you have a power supply here. So, we talked about earlier about having a scalable solution. Siemens is reusing the hardware in the ET200SP I/O family, and they're combining it with the ET200SP Open Controller. So that way, we're using the same hardware. There's no difference here. We're using the same software that we'd be using in any other PLC, and that makes it for a really neat solution. It's a really compact solution. So you get a PLC, a Windows operating system, and I/O, all within a couple inches here. So it's a super high functioning piece of hardware. So we were talking about those bus adapters for those RJ45 ports. So you can see Siemens has a couple different options here for up to 100 meters. They have its Ethernet, so RJ45. Siemens also has something called Fast Connect. So they have their own RJ45 connectors. They have a tool to make this super easy. So in the field, you're not sitting there and trying to wire the 8 pins, the 4 twisted pairs that would go in there. Instead, you just insert the cable, it cuts it, it puts the wires in the correct location, and then you just snap the connector on. And then about 4 or 5 steps, you're done. You can ensure that it's a good termination, and you're not going to have any problems with connection. Moving on up to 300 meters, we get some fiber optic and RJ45 Ethernet combinations. Ethernet are still going to be 100 meter, but the fiber optic is where we get up to 300 meters. And then if we need 2 kilometers here, this is when we get into the higher grade fiber optics. So these can be put right on the PLC, the open controller, which is a great solution if you got if you're doing a tunnel or something where there's long distance between the PLC and your automation. Looking at the hardware for the operating system, that's Intel quad core here, 1.6 gigahertz. I mentioned the 8 gigs of RAM. We mentioned the display port, the USBs. So there's 3.0 and 2.0 on there. There's also a slot for a 30 gigabyte CPAS card, but you need some more space there, some more memory. In addition to, there's also the SD card as well. So 2 different memory cards you can put in there if you need to store some data. Software, I believe it's on version 2.7 now for the firmware. There is an option, pre-installed bundles, which we'll see. We have a slide with part numbers, but you get the standard controller, you can get the fail-safe controller, which is for safety, or you can get an option with the actual HMI, the WinCC software on the Windows operating system. So it's a pretty neat solution now. You combine the I/O, you combine the PLC and the Windows operating system, and you put an HMI package on there as well. So it really is an all-in-one solution. And then last bullet point here, we have support for SIMATIC ODK. So that's the open developer kit. So that's what's going to allow you to take advantage of C, C++, or Visual Basic, or another programming language. It's going to let you be compile down that your program into a file that the PLC can access and read and execute. Going on to the operating system. So currently we're doing Windows 10 Enterprise 64-bit with the LTSP option, long-term service. And in addition to this, there's also a Linux option. So Siemens recognized the issues they were having with Windows not maintaining operating systems, and just canceling support for them. And, that may be fine for commercial devices, but for industrial devices, we need to stay in operation for 10, 15, 20, maybe even 30 years. So Siemens is actually creating their own operating system. They're going to be calling it Industrial OS, and it's going to be based on Debian 9. So it shows down here in the bottom center, test runs with Debian 9.4 and 9.6. So that's just something to look out for. Some people, they prefer a Linux system over a Windows system. So that advantage is there. And the ET200SP family, we've kind of talked about that already. It's the same I/O modules that you would use for your remote I/O. You can attach it right to your PLC. Some of the specs here. So it is ATEX approved here, and we have some vibration resistance. Again, we have no moving parts in here, so it helps quite a bit. And then as far as the ATEX, it's keeping voltages under a certain level, not letting any sparks occur to prevent any explosions. And as far as storage and operating temperatures, so we can operate up to 60 C, negative 20 C, altitude of 2,000 meters. And I believe there's an increased version of this. I can go up to 5,000 meters too, if that is an option that you need. As far as the USB load, so the 3.0 is 1 amp, 2.0 is 0.5 amp. And then here are some of just the standards that it was tested to. So as far as vibration and shock resistance, the IEC standards. So how does the controller stack up to Siemens other controllers? So it's about in the middle, a little bit more on the higher end. On the bottom left, you have the Siemens basic controllers, which is the 1200. Then you have, where we get into the advanced controllers. And this is, the open controller really sits between the distributed controllers and software controllers, because it's a software controller running on the hardware, but it's acting like a distributed controller where you can add the I/O modules to it. And before I continue on, I just wanted to see, are there any questions currently? I don't know if mics are going to be available, but I know there's a chat box that you can take advantage of. So if there's anything in there, I'm looking at it now, I don't see anything. All right. Well, I'll continue on here with the presentation. So just looking at the other PLCs, you have your standard PLCs, which go from your 1511 up to your 1518. The blue F stand for a fail-safe option. So if you already get fail-safe, you get a little bit more memory size, and that's to handle the safety program. But as you can see, performance is the same across the board. Moving on from the standard CPU, you go to technology CPUs. Technology CPUs are meant for motion control. So you can see in the bottom row here, there's extended motion control resources. And basically what that is it allows you some additional functionality for functions within motion control. So if you're going to do camming, gearing, synchronous control, those consume what Siemens is calling extended motion control resources. And based on your program and how you use them, you only get so many in a controller. And there's actually a note 4 down here where it kind of talks about, speed set points takes up 40 control resources, positioning is 80, gearing is 160, output cam is 20, cam track is 160. So just to give you an idea of what the amount of resources that we use for certain applications. And then all the way on the right is when we get into our ET200SP open controller. So we have two versions of this. One is the standard version. The other one is the technology version. So if you wanted to do motion control applications with this controller, you absolutely could. An important note to make is the bit performance here in the middle. I'll get my laser pointer out right here. So you see it's pretty high end compared to the other controllers. The 1516 is where the 10 nanoseconds start. It's not quite 1 nanosecond, which is 1518, which is the top of the line, but we are pretty close to the higher end controller here. So you definitely get some really fast execution and to do those motion control jobs. So just kind of recapping here a little bit. So because we have the higher bit performance, we're going to have shorter cycle times. With this controller, we can integrate complex algorithms. So the stuff written in C++, C or VB, and outside application, something that you want to do in ladder logic or something like that, you can now integrate that into your PLC. So the memory was significantly increased compared to the other PLCs, which helps out with storing data on the controller. itself. Again, integrating into PC applications. So there's that joint link there, and then we kind of touched on the multiple tasks that it can do. So it's a controller, it's an operating system, it's an HMI all in one. We have the ET200SP modules, and then the integration of third-party software, because we're running Windows on this, or Linux, you can run an application right on the PC. So it's a very unique controller. So getting into the separation of Windows and Siemens Step 7 operating system. So you can see here in the graphic on the left, we have what's called Siemens Hypervisor. So this is down at the kernel level, and this actually creates the separation of the hardware resources for each operating. I don't want to keep going over the same points here, but mentioned kind of some of the security, optimal security, know-how protection. We'll go in that and more. We'll go into more detail there in a minute. Communication. This is an important topic. Communication between controller, HMI, and other Windows. So again, we have access to the HMI. There is an onboard web server. So if you wanted to just access your PLC and you didn't have TI portal or some software tool, you can actually just, as long as you have a browser and a connection via Ethernet, you can type in the IP address of the PLC, open up the web server, and there are a number of functions in there. Obviously, status, getting diagnostics, seeing what caused the fault. You can look at watch tables or tags with the values of specific tags. There's trace functions in there. So if you wanted to set up a trace that, say you have something faulted, the PLC or the drive fault, well, you can actually set that up so that you can go back in time before the fault started and after the fault started, or after the fault occurred, and see what certain tags were doing in that time. So it's a pretty unique feature, and it's been really beneficial for me whenever I've done commissioning or startups. But to get back into the communication, OPC UA server and client is supported on this. And then also you have your TCP and UDP functions through Windows as well. So just looking at the storage here between software controller and Windows. So you can see it's broken up into different sections, and they don't actually overlap, so they're not going to be sharing the same memory. It's partitioned and separated, so that way, there's no chance of data getting corrupt or losing any of the memory. So yeah. So wrapping up everything here, on the left side, we got, what did Siemens set out to do? They wanted a compact solution. They wanted something that was scalable. They wanted, to be able to expand it. And security was also a huge function. So, we kind of talked about what came out of that with the table on the right here. And so we have a controller that's quite capable of doing pretty much anything and everything that you could ever need. So jumping into some unique functionality here. So I haven't mentioned really the TIA portal yet, but the software controller is programmed with the TIA portal just like any other Siemens PLC or automation hardware would be. Some advantages of that is the integrated system diagnostics. So that's built into the firmware of our devices, of all of Siemens devices. So the diagnostics is literally a checkbox. You just enable it, and then you get the same diagnostics, whether it's the PLC diagnostics buffer, whether it's through the web server, whether it's on the HMI and alarm window. The text is going to be the same. It's going to tell you what the error is, what the issue is, and it's going to tell you potential remedies for that issue. So it's a really, really unique function, and you don't have to spend a bunch of time programming, all these checks and balances in to ensure that you're getting the right message about your device. And simple integration of high-level languages in step 7. So that's the putting in C and C++, Visual Basic, some Python, and being able to execute that with the step 7 operating system. We've mentioned the ET200SP family, so we're able to put the I/O modules on the PLC. And one thing we didn't mention is it can go up to a total of 64 I/O modules. So it's quite a large amount of I/O. And then if you needed more, you could always do a distributed controller or distributed I/O, remote I/O. So you can just get an Ethernet connection, get an interface module, and add more I/O to that interface module to do a remote I/O rack. This is a really neat option, the option handling or configuration control. So what this is say you're an OEM and you're building a product and you have a couple different variations of this product. So I know the one example that I fall back on is a baking machine. So say you're baking muffins or something. So if you're an OEM, you make this muffin making machine, and you have a couple different variations of this machine. One variation is it just makes muffins and it doesn't handle packaging. Another variation of this machine is that it actually handles the packaging as well. So with those two variations, there's different hardware, there's different I/O. And as an OEM or as a programmer, you really don't want to maintain different code. You want to have one code that can do everything, or one project that can do everything. So what configuration control allows you to do is to set up those different hardware variations inside your project. And then when you start up the system, the user would then select, okay, what kind of system do they have? Or you can detect based on the hardware, what kind of system do I have? And then it would know which version of the code to execute. So it's a really neat feature. It's not hard to implement. It may sound complicated. It's a little bit different than just putting your regular I/O and program into a project. But it's a unique solution, and it's great for OEMs that they have one product and a couple of different variations there. So everywhere it's there. If you have any questions about it, just ask me. Again, it's called configuration control. So you can Google that as well. Siemens application example configuration control, and you'll see what you can do there. Moving on to safety functions. So I mentioned there's the fail-safe I/O. There's fail-safe PLC. So you can get all that built into one device. A lot of other vendors require you to buy separate safety devices, so like a separate safety PLC, separate safety I/O. Siemens allows you to do that all in one. So you're gonna have your TI portal programming environment, and when you put a fail-safe controller in there, you're gonna have your blocks for your standard code, and then you're gonna have your blocks for your fail-safe code as well. So there's no additional hardware or software necessary. Let's say software. There's a safety license that you have to get for the step 7, but everything's all built in one, and you can reuse a number of the code between the standard and fail-safe program. So functions there. So we kind of touched on the technology controllers before. This is just showing a comparison of distributed controllers versus software controllers. So software controllers don't have all the functionality that a distributed controller has. The distributed controller has dedicated hardware, so that's why it's able to run some of these technology functions or the motion control functions, whereas the software controller doesn't have that. So it can't give you that determinism and that fast execution. It can't be guaranteed like it could in a distributed controller. And again, when we talk about motion control or technology functions, speed control, positioning, output cam, gearing, kinematic functions, robotics, any tracing, or you got a flying saw, or so you got a moving conveyor, and you got to have a robot that's moving with it. That would be a good example of motion control functionality. We kind of touched on this before. So Windows 10, 64-bit version, long time service branch, 10-year support, which is better than what they've done in the past. And but like we said, Windows or Siemens has Linux coming as well. But yeah, if you order the Open Controller, as we'll see in the next slide, we have versions with Windows right here, and then we have versions that are Linux ready right here. So these are all the different part numbers for these controllers. So because there's so many different options, as far as going with a fail-safe, non-fail-safe, or standard controller, with an HMI, with Windows, with Linux, with the technology options, that's what brings on a lot of these different part numbers. So, if you're interested in using this and you have some questions, just get in touch with me or anyone at High Tech or within Siemens. We do this stuff every day, so we can really narrow down what you need and pick out the right part number to get you going with your project. Going to take a quick break here. Is there any questions or anything at the moment? I'm going to check chat box here. Don't see anything in the Q&A section. All right, well, I will continue on then. So getting into the software and programming the Open Controller. So with Siemens, they have a software package called TIA Portal, Totally Integrated Automation. This tool is an all-in-one tool that will let you program anything and everything in Siemens automation portfolio. So PLCs, HMIs, network switches, drives, power supplies, contactors. Yeah, I think it's the network switches already. I could be forgetting about some. The remote I/O. Anyway, everything and anything you need to program will be in TIA Portal. It's a really great package. In the past and still today, some vendors make you get 20 different software packages. Or I should say a software package per device. So for a drive, for a PLC, for an HMI, they all have individual software packages. Siemens is really leading the way in creating one tool to integrate everything. And so as I said, so there's the step 7, which lets you do controllers and distributed I/O. You can get into the networking with Profinet, connect everything over there. Start drive will let you do VFDs and drives. Getting into advanced motion control drives, we're going to need a Scout. So then the HMI, WinCC, the IPCs for industrial PCs. And so just the common data management. So this is, think of it as a database for TI Portal. So basically what this allows you to do is any tag, whether it's in the PLC, in the HMI, or in the drive, you're going to be able to quickly drag and drop that into your PLC programmer, into your HMI screen. Because it's all in one software package, it's all connected and it all is integrated very well. Another thing about the common data management is that, say you change a tag in one place, well, that tag change is going to be updated throughout your project. So before, you made a tag change in your PLC code, well, then you'd have to export that tag list, import it into your HMI software, and update it. Now it's not necessary. Once you make a change, you compile your project, and it knows where that tag was used, and it will update that automatically. The security integrated, so all the fail-safe functionality is built into the TIA Portal. And then also diagnostics across the board. So all the diagnostics is integrated with a single checkbox, and you get it in anywhere. It'll all be the same text, whether it's in the HMI, the PLC. Yeah, you get one consistent version there. We're just kind of going over what I said already, but yeah. And just to drive it home, everything you see here is done inside the TIA Portal. So I mentioned most of this already. I didn't mention stuff like CNC controls or the industrial controls, so like starters or current transformers for metering power. The power supplies, those can also be hooked up on Profinet. You can get data into the PLC and in the TIA Portal. And then the energy management. So all this can be tracked and traced and controlled at a high level of, okay, say you got a conveyor running, okay, well, nothing's actually moving on the conveyor. Let's shut that down. Let's turn that drive off to save energy. So there's a lot of functionality here built into one software package. And real quick, I just wanted to go over the licensing. There's a number of options available with the licensing. So basically, for TI Portal, there's two versions of TI Portal. There's a basic license and a professional license. Basic will let you do the S7-1200 controllers only. There's a safety option, as I mentioned earlier. But then when you step up to the Step 7 professional version, you can do all the PLCs and all the devices. So this includes 1200s. This includes the 300s and 400s, which are the controllers Siemens had back in maybe the 90s. That are still available, still in many applications around the world. You have the new S7-1500 controllers, then you also have the open controller and software controller. So it's all supported under one Step 7 professional license. Again, you have the safety. So if you're doing any fail-safe applications, you have a license for that. And then this also includes PLC sim. So if you need to simulate your PLC, you can do that. Start drive, which is for drives. So if you wanted to hook up your drive and get all your data and parameters and commission it, you can do that. And then WinCC Basic is for a very simple HMI. So that's all included in the professional package. So just to expand on the licensing options, so on the left side here, again, Step 7 and safety. We covered those already. Then to the right, SIMATIC WinCC. So that's their HMI SCADA package with WinCC. And there's 4 different packages there: basic, comfort, advanced, and professional. Yeah, and it's a tier system. So basic, you have a simple panel, and you just want to see a few values on the screen or enter a few values. That's good there. The comfort and mobile panels, if you want to take advantage of object-oriented HMI designs, say you have 10 motors, you have one base plate or one object for a motor. We just reuse that and instantiate that throughout your HMI. So that's where comfort panels really come into play, and that's a unique feature they have. They also support Visual Basic scripting. So if you want to do anything with that, that's there. Advanced and professional, this is when you get up to your SCADA system. That will be when you're actually you want to put WinCC on a PC, on a server. You would get one of those packages. Advanced is for a single PC station. Professional is for multiple. So if you're doing a whole site-wide, wastewater plant or a whole factory, that's where you look at professional. Motion Scout, I mentioned, that's going to be doing the advanced motion control, regen applications, bigger drives. Start drive is your basic drives, so your general purpose and some small servos. And then soft starter and SIMACode, this is your industrial control products. So SIMACode is really for metering and doing motor management. So you can control your motors. You can get data off the main incoming breaker. And again, it's a modular solution there. In addition to those licenses, you also have some options here. I'm not going to cover all of these, but I'm just going to go over some of the main ones. So you have multi-user engineering. This is if you have multiple engineers on a team working on the same TI Portal project. Basically, they have their own separate instances, and they're able to bring them together and not overwrite changes and things like that. Cloud connector. This allows you to basically store your software and your license on a central server, and then say you're a maintenance tech, you bring your laptop out to a PLC. You don't have to have any of the software licenses on your laptop. You would just check into the central server via the Portal Cloud Connector, and it will actually create similar to a remote desktop link. But it's pretty seamless, and you'll be able to then download it and hit the PLC and use the software there. Mentioned PLC Sim Advanced, so if you need to simulate your PLC and simulate your communication, that's there. The safety we kind of talked about. Here's the ODK, the 1500S option. So that's for doing the open controller and working with C++. And then some of your runtime. This can be on your HMI. So ProDiag is diagnostic. So what that's for is you can actually display ladder logic and PLC code on the HMI without any other software. So, you know, if you have a maintenance tech or an operator and they don't want to see why is this step not progressing or why is the PLC stopped, that ProDiag is a tool there that you would use. And then last but not least, OPC UA. So yeah, if you need communication to, you know, a bunch of other third-party platforms or devices don't communicate, usually OPC UA is a way to go there to get that going. So real quick, SIMATIC ODK. So this is the Open Developer Kit. So this is the engineering package that's going to allow you to develop your C or C++ applications for a Step 7 controller. So, you know, it's going to give you access to databases. You can implement different communication protocols and IT software. So it's using the Eclipse IDE. And yeah, so as far as the software packages that stack up here, Target 1500S, this is optional, not required. Again, the Microsoft Visual Studio C++, again, this is optional. And then the SIMATIC TIA portal. So really the only thing you need is TIA portal and the ODK. But if you want to take advantage of some advanced features, you get the Target 1500S and the Visual Studio. And then as far as the runtime, what's actually on the controller is the software controller license. And this comes with the PLC when you order it. So that's the software packages. And then just some highlights of the ODK. Again, decoupling of Windows functions through asynchronous operation. You get to preemptive execution of the ODK runtime application. You have function blocks within Step 7 that are going to call your ODK applications or functions. Yeah, different apps. You can run Visual Studio, you can run Eclipse. It doesn't matter what platform you use to program in, as long as you compile it down and use the ODK, you'll be able to access those functions. You get the sandbox environment, so that way you're not going to destroy running, you know, so you got a control system up and running. You can create that sandbox environment to test your code before you actually deploy it and know that it works. And yeah, and then calling out Windows DLLs, of course. So again, yeah. So the C++ is here. Something new is the MATLAB and Simulink. So if you're doing modeling, you can take that code as well, compile it down, and then access it to the Step 7 platform. And just here with some advantages of, so Siemens has their structure control language, SCL, which is a high-level language, but it may not have all the features and benefits of C++. C++ has been around for a long time. It's been the basis of a lot of embedded hardware, and so there's definitely some efficiencies there when it comes to using that language over another high-level language. I mentioned access to a database, so you get, you know, direct access there. Saving files, dealing with different file formats, that's another benefit. Connection of computer hardware, so sometimes there's devices that don't hook up to a PLC easily. Well, they can hook up easier to an actual computer operating system, so vision systems, scanners, printers, and different protocol implementations here. Looking at the execution, so in the software, with the open controller, you have the Windows side and you have the software controller side. Your ODK application here is going to have different functions that you're going to compile down to your DLL files. In your software controller on your Step 7 side, so in your OB1 or your main OB, you're going to have different function blocks. And these function blocks are then going to call the DLL functions. and then they're going to run, execute, and store their data into this SO data block or shared object. And just to see what that would look like, here are the function blocks in step 7. So ODK runtime app sample function, and then there's synchronous and asynchronous interfaces here for the blocks. So these are the blocks that you are familiar with if you've used TI Portal before. And so this is it's as simple as this for accessing the C++ objects. You just put a block in, you put the right parameters in for those functions, and you're able to then execute those in step 7. Getting into security and protection. So, with PCs, it's definitely a concern. And, as anyone who develops a program, you're concerned about your intellectual property. So the first step here is know-how protection. Know-how protection allows you to lock down your intellectual property, your blocks. So all your function blocks, your function control blocks, you can actually put a little lock on them. And basically, without the password, you're not going to be able to get into it. You're not going to be able to see it. You're not going to be able to compile it, anything. You're just going to know it's there, but you're not going to be able to know, what's going on the inside of that. There's also something called copy protection. So this will allow you to bind your program either to the hardware, the IPC motherboard, or to the SD card serial number. And basically what that means is that your code, like say you bind it to just the hardware, your code can only run on that hardware, on that PLC. So if that PLC fails, then you can't just get a new PLC and run the code on that. You actually have to go back to the TI Portal project, compile it with the hardware, get the new serial number, and then deploy it. On the flip side, if you use the SD card, that your program will only run on the mass storage with that card. So say PLC fails, take out the bad PLC, you put the new PLC in, you put the card in, it'll execute no problem. But now someone can't go in there and just take the card and copy data off of it. Or someone can't go into the PLC and just copy your data. They actually need the physical card with that serial number in order to execute your code and copy your code. And then access protection. So there's 4 different levels of access protection here. So it might be a little bit small, but in the background here we have full access, read access, explain access, and no access. So that's for getting actual access to the PLC, downloading to it, compiling it, reading it. Different levels there you can set up with passwords. And with that said, that's pretty much it for the Open Controller. Just so you're aware, High-Tech is always doing trainings and more upcoming events. Just go to hightech.com/events. We have webinars, we have workshops, in-person trainings. We can also come on site or to an office to train a group of people. So yeah, that's there. And then if you guys have any questions, now's the time. Again, I think the microphones are disabled, but we can use the chat box. And then if there's any questions we got to take offline, feel free to email me or reach out to me or anyone at High-Tech, and we can go over that. So at this time, just open it up for questions. Don't see anything in the Q&A box.
No, I don't see anything yet, Vince.
All right. I'll give you guys a minute here. All right, well, nothing's coming in, so if you guys don't have anything, that will conclude this presentation. All right, guys, thank you for coming. Appreciate the time. Hope you learned something new, and yeah, look forward to hearing you next time. Have a good one.